In the winter of 2019, the American Midwest and Northeast turned into a real-life disaster movie. I'm talking about that time when temperatures dropped to negative 63 degrees Fahrenheit. There were massive flight cancellations and power outages, dozens of injured people, and shut down schools and offices. Simply going outside became highly risky. And if you're looking for someone to blame for all this, I've got two words for you: polar vortex. That's not some scary storm, but a huge mass of cold air that's normally spinning counterclockwise around the poles. When it's summer up in the northern hemisphere, the vortex stays further north, and in the winter, it heads south a bit. The term polar vortex has been around since the late 1940s. It shows up every winter and calls it quits in the spring. But for about the last 20 years, this polar vortex has been acting weird in the middle of winter. It looks like it either splits or becomes displaced once every other year. At the bottom of this vortex is what they call the polar front, or the polar jet stream. This jet stream moves from west to east, which is why places like the northeastern part of North America get hammered by that chilly polar vortex weather.
Ooh.
These jet streams zip along because of differences in temperature and the Earth's spin. When there's a big gap in temperatures, the winds really pick up speed. In spots like the equator, where the sun's rays are more intense, the air heats up and starts to rise. And as it goes up, it leaves behind a sort of empty space, taking in air from all around, kind of like a huge vacuum cleaner. But over at the poles, where it's way chillier, the air shrinks and sinks, forming areas of high pressure. It's like a bunch of air molecules trying to spread out, like a group of school kids on a big field. So you've got these two forces at play: warm air rising and cold air sinking. Air wants to zoom from the poles down to the equator with this setup. The jet streams tend to hang out where airplanes fly, about 30,000 feet in the air. Pilots often use them to zoom across the sky faster and save some fuel. But these jet streams aren't always the good guys, as they can bring all sorts of weather changes, like cold snaps and heat waves. When the polar jet stream is strong and cruising at about the same level as the vortex, it kind of locks in that cold Arctic air within the Arctic Circle. Every now and then, the jet stream takes a chill pill and starts moving around the planet in a wavy pattern called Arctic oscillations. This creates peaks and troughs that allow warmer air from down south to head north, and the chilly Arctic air to take a trip south. In the northern hemisphere, there are two polar vortexes, one in the lower atmosphere known as the troposphere, and another higher up in the stratosphere. The stratospheric vortex forms as cold, dense air sinks and twirls near the North Pole. The mightier the vortex, the quicker it spins, keeping cold air locked over the high latitudes. When someone or something messes with the polar vortex, it goes haywire. Picture a spinning top. Give the table a shake and it'll start wobbling. When the polar vortex loses strength, it can't corral the cold air anymore. So, blasts of icy Arctic air surge southward over North America. The polar vortex isn't a fixed object, but more like a living being. It gets stirred up by ripples on Earth's surface, triggered by stuff like air flowing over mountains or across land and sea, all warming up differently. If our planet were as smooth as glass, with oceans wrapping all around, the polar vortex would just chill out, never breaking up. But every time a wave smacks into it, it gives the vortex a push. Sometimes, one of these waves packs enough punch to shove the vortex off the pole or even spin it in reverse. And when that happens, the temperature in the polar stratosphere can skyrocket by a whopping 50 degrees in just a week. The Arctic's polar vortex started spinning in the opposite direction in March 2024 and got scientists worried. It's one of the 6 strongest flips since the 70s. This time around, it hasn't caused any chaos. Sometimes the waves of air affecting the vortex get strong enough to split it into 2 parts, kind of like how a cell divides. They're called daughter vortices, and they even add more chaos to the mix. When the vortex splits, one chunk usually heads over Siberia, while the other cruises over North America. Once that split goes down, the jet stream in the troposphere above the Atlantic decides to take a southern vacation. That jet stream usually acts like a bouncer, keeping the chilly Arctic air up near the pole. But when it heads south, that Arctic air gets a green light to crash the party in places like the East Coast, the Midwest, and even Western Europe. The storms that usually ride along with the jet stream follow along and head south too. They take their time to get organized and catch up with the new path of the jet. So, instead of hitting up Canada like they usually do, they swing by New York and Chicago for a change of scenery. Scientists still don't know why the polar vortex doesn't mess with the U.S. Pacific coast. It might have something to do with where the jet streams hang out in each basin. Over in the Atlantic, the jet stream kicks it at higher latitudes, while in the Pacific, it's chilling closer to the equator. It might also have to do with the landscape. In the Atlantic, the air has zipped over the Rocky Mountains, stirring up waves off tall peaks that mess with the jet stream. But in the Pacific, the jet stream is away from any big mountains that could cause trouble. The recent reversal of the polar vortex is unlikely to make the temperatures drop extremely, but scientists aren't sure what's going to happen to the polar jet stream in the future. They're concerned that the chilly polar air might make more trips down to the mid-latitudes and bring along more chilly spells in the long run. So it's better to be prepared. When the news tells you there's a huge winter storm coming and power outages are highly likely, fill your bathtub with water. If you have an electric water pump, it won't work and you'll run out of water soon. Gas stations also run on electricity, so fill your car tank before the storm hits to have some emergency gas. When the storm arrives and you're locked in, put on several layers of warm clothes, thermal wear, a warm shirt, a sweater, and insulated pants and woolen socks. Don't forget mittens so the heat doesn't escape through your hands. Hang dark blankets on your windows to draw in heat. Make sure your doors and windows are closed well, and put some towels under them to prevent drafts. Your basement is probably more insulated by the ground, so it could be a good place to spend the night. To warm up the cold winter bed in your home, fill a bottle with hot water and place it in your core region under the cover. The water will heat up your vital fluids traveling through your body, reaching all the extremities and warming you up in no time. You can also wrap your pajamas around the bottle before putting them on for an extra effect. When the power comes back on, check all your appliances and electronics before turning on the main power switch. They must be unplugged to avoid power surge damage. As you turn the water supply back on, keep the taps on the lowest level of your house closed to let the air out from the upper taps.
A sinkhole suddenly appeared in northern Siberia. This 115-foot deep hole popped up after some weird explosion that threw dirt and rocks almost 395 feet away. Since then, 2 more mystery holes have shown up in the area. People first thought it might be connected to digging for fossil fuels, since it's not far from the biggest gas field. But the search team's radar scan suggested it was probably a natural thing. The first research trip wasn't too successful because scientists couldn't get inside and take samples until the hole's sides and the water at the bottom froze. Scientists have been wondering about what caused these holes, and the ideas varied from space rocks hitting the ground to rising temperatures on Earth. One researcher suggested that the eruption had occurred due to the accumulation of pressure. A temperature decrease is often accompanied by alterations in the volume of specific chambers. These chambers contain methane. Such craters are specific to the Arctic region. Few other areas share these particular features. They all have table-like ground ice situated close to the surface, continuous permafrost saturated with methane, and unfrozen ground. Speaking of gases, a geologist suggested that the sinkhole might have been caused by gas hydrates. These gas hydrates are also thought to be responsible for mysterious happenings in the Bermuda Triangle. The Yamal Peninsula, similar to the Bermuda Triangle, has been a place known for unexplained events. Here, residents even claim to have seen the abominable snowman. Sinkholes can pop up out of nowhere. Some are massive enough to gobble up whole buildings. They happen when rock under the ground, like limestone, starts getting dissolved by the water it contains. As the rock melts away, these big holes, or caverns, start forming. When these caverns become too much for the land above to handle, bam! The surface caves in. Ice is melting like crazy. The Arctic is warming up way faster than the rest of the world, so ice sheets and glaciers are shrinking. As these chunks of ice melt, they pour fresh water into the oceans, raising sea levels and making Earth's crust sink. During the last ice age, those massive ice sheets pushed down on Earth's crust, making it bend and sink. When the ice started melting, the crust began to bounce back. But now, the ice is melting too fast for the crust to keep up. This sinking situation creates a dangerous loop. As land goes down, more seawater creeps in, causing more erosion and flooding. What about other parts of the world, such as China? It hosts the deepest and largest sinkhole on the planet. This sinkhole is 2,165 feet deep and holds a crazy amount of space, 130 million cubic meters to be exact. They call it the Heavenly Pit, and it's not just big, it has its own mini ecosystem. 1,285 different plant and animal species can be found there. There's an ancient forest and a thick jungle of plants in there. This formation is a double-nested sinkhole with two craters connected by a sloping edge. When it rains, a waterfall shows up at the mouth. It feeds an underground river and cave network. When you look down from space, you'll see these deep, dark marks on the green landscape, like a footprint. Some suggested that these formations could have been left by a meteorite smashing into Earth. Others said it had taken about 128,000 years for water to carve them out. It could have snuck into underground rivers and worn away the limestone rock. It turns out, locals have known about this place for ages, but the rest of the world only caught wind of it in 1994. British explorers tried to map out its underground cave system, but it's like a maze down there. After 5 tries in a 10-year span, the team couldn't handle the rushing river and had to throw in the towel. So, this deep, mysterious underworld remains one of China's biggest geological puzzles. The next one is Crveno Jezero in Croatia. This is a huge, mysterious pit. It's not like a regular lake. It's basically a giant hole that formed when the ground collapsed into what was once a massive cave. The walls are super steep and have this reddish tint because of iron in the soil, which makes it look pretty wild. Inside, there's a deep blue lake that's incredibly clear, but also super cold. What's really cool is that it houses a unique species of fish that's only found there. Plus, the water level goes up and down because of an underground stream. It's a bit of an adventure to explore the lake because it's surrounded by sheer cliffs that can drop rocks without warning. Let's shift our gaze to Venezuela's Cima Humboldt. This is a colossal sinkhole hanging out in a flat-topped mountain. This beast of a hole plunges down 1,030 feet. You can find an entire forest at its base. It's home to many plants and animals that only live there, like a unique frog called Stephania rhei. In 1974, people went on an exciting trip there for the first time, and they had to cut down trees so that helicopters could come and pick them up, kind of like something you'd see in an Indiana Jones movie. The second largest blue hole on the planet, known as Tamya, which translates to deep water in Mayan, is in Mexico, and that's where we're going. This underwater marvel was uncovered off the shores of Mexico's Yucatan Peninsula in 2021. But the deets about this sinkhole have just surfaced recently. It's 900 feet deep, with the sides so steep they're almost 80 degrees. The entrance to this cavern is about 15 feet below sea level. Blue holes like Tamya are these natural wonders formed during the ice ages. When the sea level was way lower, rain and other natural elements eroded limestone, creating these deep, vertical shafts. Then, as the oceans filled back up, these holes got submerged, turning into the mysterious blue holes we see today. They're called blue because the deep parts are darker than the shallower waters around them, making them look striking from above. Despite being low in oxygen, which usually makes it tough for sea life to thrive, blue holes are bustling with unique forms of life, especially bacteria. They're also gold mines for scientists because they can preserve ancient fossils in conditions you wouldn't normally find elsewhere. The team that discovered Tamya used scuba gear, sonar equipment, and water sample testing to map out the blue hole and study its water chemistry. They found that it was not just deep, but also massive, covering a surface area of 147,357 square feet at its widest point. This discovery was made partly thanks to local fishers who had been whispering about its existence. Now, scientists are diving deep into its secrets, hoping to learn more about the unique ecosystems that blue holes can host, and how they might give us clues about handling climate change and preserving marine life. Another spot is Dean's Blue Hole. This one is just off Long Island in the Bahamas. This underwater wonder goes deep, reaching 663 feet. The massive blue hole is surrounded by rocks, a lagoon, and a pristine white beach. Dean's Blue Hole isn't just a pretty sight, it's a hotspot for free-diving enthusiasts. People come from all over the world to take the plunge into its crystal-clear depths. There are multiple passages branching off from the main blue hole, leading into intricate cave systems and mysterious underwater rooms. It stands out also because it's the second deepest blue hole in the world, falling just behind the Dragon Hole in the South China Sea. This place is a big deal in the scuba diving world, especially since a swimmer set a world record here by diving 331 feet deep on a single breath without any fins.
The Arctic is disappearing. In just a few years, the North Pole could see its first ice-free summer in the last 125,000 years. But a bold new experiment might turn back the clock. Scientists are refreezing the Arctic. If they succeed, they could save the North Pole. But if they fail, they could trigger unforeseen disasters. So, which way would things go? Well, here's some backstory. Deep in the Arctic, temperatures drop so low that metal cracks and winds scream across the ice. In winter, it's minus 30 degrees Fahrenheit on average. But despite the seemingly extreme cold, it's actually melting, warming 2 to 3 times faster than the rest of the planet. Now, ice is like Earth's natural mirror. It reflects sunlight back into space, keeping the planet cool. When it melts, it exposes the dark ocean underneath. The ocean absorbs sunlight instead of reflecting it, and it spreads all across the planet. This warms the planet even faster, melting even more ice. It's a vicious cycle, and if it continues, we'll reach a point where the ice won't come back. That thick, ancient ice that has covered the North Pole for thousands of years is already 95% gone. It's been disappearing since the 1980s. The ice that remains there now is thin and fragile, and when it disappears, it will trigger a dangerous chain reaction. Meanwhile, a group of researchers from a UK startup called Real Ice is out there trying to slow down or even reverse the melting of the Arctic. The project takes place in a tiny frozen village in Canada called Cambridge Bay. Real Ice wants to break the vicious cycle, and here's their plan. First, they drill through the existing ice and place an underwater pump beneath it. Then they pump seawater onto the ice surface, where it quickly freezes into an extra thick layer. Finally, they remove snow from the ice, which usually acts like a blanket, preventing further freezing. After that, ice keeps growing, stronger, thicker, and harder to melt. It's a simple idea inspired by nature itself. Ice naturally forms this way in some Arctic regions, but now scientists want to do it on a massive scale. So far, it appears to be working. Between January and May 2024, they covered around 44,000 square feet of ice, and it became 20 inches thicker on average. And in November 2024, they started a new round of tests. In the first 10 days of the trial, the ice was already 4 inches thicker. Now they'll return in May 2025 to check out how things are going. They think it's going to get between around 16 to 31 inches of it during the Arctic winter. It's a small start, admittedly, but if they can prove it works, their plan is to expand across an area more than twice the size of California, about 386,000 square miles of ice. And they're not stopping there. The big idea is to send in 500,000 underwater drones, powered by clean energy, to automate the entire process. These drones would drill holes, pump water, and refreeze the ice without human intervention. But not everyone is convinced. Some scientists think this whole idea is a disaster waiting to happen. First, they point out that saltier ice, the one from seawater pumped onto it, melts faster in the summer. So if this new ice melts too quickly, we could end up making the situation worse. Some of them also think this is a dangerous distraction from the core problem, like treating the symptoms instead of the root causes. Besides, making a small patch of ice thicker is one thing, but doing this across the entire Arctic? That's another challenge entirely. Another thing they're worried about is the ecosystem. The Arctic is one of the most fragile ecosystems on Earth. Changing ice thickness could affect marine life, disrupt algae growth, and impact the food chain in ways we don't fully understand. There's also the question of money. Real Ice estimates that refreezing the entire Arctic will cost about $5 to $6 billion per year. Who's paying for this? Right now, they're self-funded with some investors backing them. But eventually, they hope that countries, global funds, and even corporations will finance the project. Real Ice argues that doing nothing could be far worse. If we don't act, we could lose the Arctic within our lifetime. That could at least help to buy more time to fix the planet. Desperate times call for desperate measures. Now, the idea of saving the Arctic ice isn't new. Over the years, scientists have suggested some pretty wild plans to stop the melting. In 2017, there was the initial wind-powered pump plan. Physicist Stephen Desch proposed installing about 10 million wind-powered pumps in the Arctic. These pumps would pull seawater up onto the ice, kind of like real ice. It would freeze in the cold winter months, creating a thicker ice layer. The biggest problem is that someone would have to run this entire show. And what happens if something goes wrong? In 2018, there was the Glass Beads Plan, which was supposed to start in 2020s. A team called the Arctic Ice Project suggested covering the Arctic with tiny reflective glass beads. Yep, glass balls. The idea was basically to replace the ice's mirror effect. The beads would bounce sunlight away, keeping the ice colder for longer. The plan is being tested by a group of scientists working with the Arctic Ice Project. They say the glass balls are made of a material that's safe for animals. They even claim birds use similar materials to help them digest food. The glass used in these microspheres is the same material used in lab equipment and light bulbs. Sounds safe, right? Well, not so fast. There's also the environmental risk. These glass balls are tiny, and they could easily get into the ocean, impacting everything from fish to plankton. We still need more research to understand how this material breaks down in the ocean and whether it could affect marine life. But where things get really crazy is when we start talking about scaling this up. To cover just a tiny fraction of the Arctic, they would need millions of tons of these tiny microspheres, and that's just for starters. And they'd have to be working 24/7 through freezing temperatures and snowstorms. The scientists believe this could help keep the ice thick enough to survive summer and even slow the melting. But can it really work? Then, there's also the Bright Ice Initiative, founded by the same folks behind the Arctic Ice Project. Instead of focusing on the Arctic Ocean, they want to use the same glass microspheres to restore glaciers. They've even tried this out on a glacier in Iceland, but experts are still skeptical. They say it could just speed up melting instead of reversing it. Now, another idea was cloud seeding with water particles. This would involve spraying ocean water into the sky itself. This would form clouds, and they'd reflect more sunlight. So, as you can see, some of these plans were too expensive, too complicated, or just straight up wild. The Real Ice's plan borrows ideas from earlier projects, but is much cheaper and more practical. Most importantly, it's working. But all this Arctic disaster is already affecting people. In the village of Newtok, Alaska, the land is disappearing. Each year, about 70 feet of the riverbank erodes, taking homes and history with it. That's all because of the erosion and the thawing permafrost. Now, these people had to move to a safer place called Murtevik, just 9 miles away. But it's a long and challenging journey. The relocation is taking years of planning, with Newtok residents already starting the shift in 2019. The new village offers better health and safety, but it's still a work in progress. Things like the school and grocery store remain in the old village, which makes things harder. Water and sewage systems are being set up, and for now, most residents are using a honey bucket system. But at least they have a chance to rebuild. It's still unclear whether these geoengineering ideas are a lifeline or a disaster. For now, we can just keep an eye on them.